You checked the time this morning, maybe on your phone, maybe on a clock on the wall, maybe on the watch on your wrist, some device that presented you with a number, and you accepted that number as a fact about the universe. 7:43, 10 past 9, quarter to 12. A precise, objective, shared measurement of something real, the position of the present moment along the axis of time, agreed upon by everyone, consistent across the city and the country and the world, true in the way that a measurement is true. That is what a clock does. It measures time. And time, whatever it is philosophically, is at least consistent, the same everywhere, flowing at the same rate for everyone, the neutral backdrop against which events occur. Your clock and my clock, set to the same time this morning, will agree with each other this evening. That is what synchronized clocks do. That is what time is. Except it is not. And the reason it is not was understood by Einstein in 1905, confirmed by atomic clocks flown on airplanes in 1971, and is corrected for every day by the GPS satellite network that tells you where you are. The disagreement between clocks is not a malfunction. It is not an error. It is a feature of the universe that every clock everywhere is faithfully recording. The fact that time does not pass at the same rate for everyone, that the rate at which time flows depends on how fast you are moving and how deep you are in a gravitational field, and that two clocks that were perfectly synchronized this morning will disagree with each other by tonight if they have been in different places or moving at different speeds. Your clock is not lying to you in the sense of being broken. It is lying to you in the sense of presenting a local measurement as a universal fact. The number it shows is real, but it is not the number every other clock in the universe would show. It is the number that this clock in this place, moving at this speed in this gravitational field, has accumulated. It is a personal measurement of a personal time, and personal time, followed to its logical end, says something about the nature of reality that is far stranger than a clock running slow. The answer is going to make the time on your phone feel different. Now let's be fair to the intuition of universal time, because it is grounded in genuine experience and works perfectly well at the scales we normally inhabit. Every clock you have ever interacted with agrees with every other clock to the precision you can measure in daily life. The time on your phone matches the time on the clock in the train station, matches the time on your colleague's watch. Time feels shared. Time feels like a common reference. The idea that time could be running at different rates for different people feels like science fiction. Something that might matter near black holes or at near light speeds, but has nothing to do with Tuesday morning. You might say, the relativistic effects are real, but they are so small at everyday speeds and everyday altitudes that they are functionally irrelevant. For any practical purpose, time is universal. And for most purposes, that is true. Let's check what happens when you make the measurement precise enough, because the effects are not just theoretical. They are currently being corrected for in technology you use every day. If you want to understand how the universe actually works, not just how it looks, but how it works, hit that subscribe button. We are going to take things apart and see what makes them tick. Let's find things out together. Here is the foundational discovery, and let's follow it from the beginning rather than jumping to the result. Einstein in 1905 started from two postulates. First, the laws of physics are the same for all observers moving at constant velocity relative to each other. Second, the speed of light is the same for all observers, regardless of the motion of the source or the observer. These seem innocuous. They are not. Combined, they require time to be relative. Here is the analogy that makes the logic vivid. Imagine two people standing in a train car and a light bulb flashes on the ceiling exactly in the middle of the car. Both people are equidistant from the bulb. The light expands outward in all directions at the speed of light. For the two people standing in the car, the light reaches them simultaneously. It traveled equal distances at equal speed and arrived at the same moment. Now observe the same event from the platform as the train passes. The person at the back of the car is moving toward where the light was emitted. The person at the front is moving away. The light still travels at the same speed in all directions. But now from the platform, the light reaches the person at the back before it reaches the person at the front, because the back person is moving toward the approaching light and the front person is moving away from it. Simultaneous for the people on the train, not simultaneous for the person on the platform. Two observers watching the same two events disagree about whether they happened at the same time. Not because of any error or optical illusion or imprecision, because simultaneity is not absolute, because the sequence of events depends on the reference frame of the observer. Do you see what happens? Now here is what this implies for clocks. If observers in relative motion disagree about the timing of events, they must also disagree about the rate at which time passes. An observer watching a moving clock sees it running slow, not because of any mechanical effect on the clock, but because of the geometry of space-time. The moving clock is, from the stationary observer's frame, taking a longer path through time for each tick. Time dilation is not an illusion. It is a geometric consequence of the way space and time are woven together in special relativity. The effect is tiny at everyday speeds. At the speed of a commercial aircraft, roughly 900 kilometers per hour, a clock runs slow by about 0.87 microseconds per hour compared to a clock on the ground. Unmeasurably small in daily life, measurably real with atomic clocks precise enough to detect it. In 1971, physicists Haffel and Keating flew atomic clocks around the world on commercial aircraft and compared them to reference clocks on the ground. The airborne clocks disagreed with the ground clocks by exactly the amounts predicted by relativity, including both the special relativistic effect of velocity and the general relativistic effect of altitude, which I will come to in a moment. The clocks disagreed, not by chance, by design, by the structure of the universe. Now here is the second mechanism, the gravitational one, and this is where general relativity enters and the strangeness deepens. Gravity affects time. This is not a metaphor. The rate at which time passes is slower in stronger gravitational fields. A clock on the floor runs slower than a clock on the table. A clock in a basement runs slower than a clock on the roof. A clock at sea level runs slower than a clock at the top of a mountain. The differences are tiny. A clock at sea level runs slow by about 45 microseconds per day compared to a clock in orbit at GPS altitude. But they are real, they are measurable, and they are currently being corrected for. Here is the analogy that makes gravitational time dilation tangible. Imagine space-time as a stretched rubber sheet, with the Earth sitting in the middle creating a depression. Clocks sit on the sheet. A clock near the center of the depression, near the mass, deep in the gravitational field, sits lower on the sheet in a more curved region. A clock far from the mass sits on flatter space-time. The curvature of space-time near a mass is not just the curvature of space, it is the curvature of space-time, which means time itself is stretched or compressed by the geometry. More curvature, slower time. Now I want to take this deeper, because the GPS correction is the engineering reality, but the philosophical reality is stranger and more personal. Here's what gravitational time dilation means for you specifically, stated precisely. Your head is approximately 30 centimeters higher than your feet when you are standing, 30 centimeters further from Earth's center. The gravitational field is fractionally weaker at your head than at your feet. Time runs fractionally faster at your head than at your feet. Over a lifetime, your head ages very slightly more than your feet, by approximately 90 nanoseconds over 70 years. 90 nanoseconds, unmeasurable by any biological process, completely irrelevant to your experience, but real. Your head is older than your feet. Your body does not age uniformly. Every part of you that has spent more time at higher altitude, moving faster, sitting higher in chairs, sleeping in elevated beds, all of it has accumulated time at a fractionally different rate. This is the part that keeps me up at night. Because here is the full implication, stated without softening. There is no such thing as universal now. This is not a poetic statement, it is a physical one. Two events that are simultaneous for one observer are not simultaneous for a different observer moving relative to the first. The present moment is not a global fact about the universe, it is a local fact about a reference frame. When you ask what is happening right now on the other side of the galaxy, physics does not have a clean answer. The question assumes a universal simultaneity that does not exist. The universe does not have a single time. It has a fabric of local times, related to each other by the rules of special and general relativity, with no privileged clock and no universal tick. Every clock in the universe is measuring something real, its own proper time, The time elapsed along its own world line through space-time. No two clocks measure the same thing unless they have traveled identical paths through space-time since they were last synchronized. Your phone shows you a time that has been corrected via the GPS network for both special and general relativistic effects. Without those corrections, without the engineers who understood that Einstein was right and that clocks at different altitudes moving at different speeds genuinely run at different rates, GPS would drift by roughly 10 kilometers per day and become useless within hours. Every time you navigate with your phone, you are using relativistic time corrections. You are using the fact that time is personal and variable and dependent on motion and gravity. You have been doing this for years without knowing it. Bring this back to the clock on your wall right now. That clock is measuring real time. The proper time accumulated by that clock in that location, moving at that speed in that gravitational field. It is not measuring universal time because universal time does not exist. It is measuring local time, synchronized by convention with other local clocks via networks that correct for relativistic effects, presented to you as a single number as though it were a fact about the universe rather than a fact about the path that clock has taken through space-time. The number is real. The universality is the useful fiction we agree to maintain because the relativistic corrections are too small to matter for catching trains and scheduling meetings. But the fiction is a fiction, and knowing it is a fiction changes what you are looking at when you check the time. You are not reading a fact about the universe, you are reading a local measurement of a local time, corrected by a satellite network for the personal time of orbiting clocks, presented as a shared reality because the differences are small enough that sharing it causes no practical problems. But here's what I find extraordinary about all of this, and why I keep returning to it. The fact that time is personal, the fact that every path through space-time accumulates its own proper time, that two people who separate and reunite have genuinely aged differently, that the universe does not have a single tick but billions of personal clocks all running at slightly different rates. This is not a bug, it is what space-time is. The unity of time that we experience in daily life is a consequence of the fact that we are all moving slowly relative to the speed of light and living at similar gravitational potentials. We are, in relativistic terms, nearly identical clocks moving on nearly identical paths. Our times nearly agree. We synchronize easily. We build shared calendars and shared schedules and shared histories because the relativistic differences between us are 90 nanoseconds over a lifetime. But the agreement is approximate. And underneath the approximation, every one of us is measuring our own time, along our own path, through our own slice of space-time. Your clock is telling you how much time has passed for your clock. That is all any clock has ever told anyone. And that, it turns out, is enough to build a world on. If this twisted your brain a little bit, good. That means it's working. I'll see you in the next one.